Greetings again, all. This is video 1A, Introduction to Kinematics, in the Pencrest AP Physics 1 video series. Kinematics is the study of motion. We're going to be describing the motion of objects in three-dimensional space, but initially we're going to look at one-dimensional motion. Best way to envision one-dimensional motion is a set of straight train tracks that are oriented left and right. The train can only travel on the tracks. We would say that the train is constrained to travel in one dimension. It could travel in either direction, left or right, but it has to be on the tracks. In order to thoroughly describe the motion of an object, we need to answer these three questions about it. Number one, where is the object? Has it moved? How far has it moved? Where was it before? Where will it be at some time in the future? Number two, is the object moving? If so, how fast is it moving and in which direction is it moving? And number three, is the object getting faster, slower, or neither? These questions can be answered in a number of different ways. We can describe the motion of an object verbally. For example, the object is located to the right of the origin, moving to the left and speeding up. We can also describe the motion graphically, which will be our initial focus here. We can also describe it with mathematics and computation, which will come a little bit later in the course. Now, when we describe the kinematics of an object in one dimension, we'll use specific quantities to answer the questions that we've mentioned earlier. These quantities are called vectors because they have both a magnitude and a direction. The magnitude of a vector refers to the amount. It can refer to how far or how fast or how much, depending on what kind of vector we're discussing. The direction indicates which way the vector points. In one-dimensional motion, there are only two options for direction, right or left. Later on, we'll see up and down. But for now, since there's only two options, the easiest way to differentiate one from the other is to make one direction positive and the other direction negative. Typically, we use what are called the standard sign conventions. To the right is positive, and to the left is negative. In order to answer the questions describing where an object is or was or will be, we're going to use what's called the position. Typically, the position is described with the symbol x. Position is defined as a distance in a particular direction from a fixed origin. This fixed origin is the point where x equals 0. If you think simply of a number line, look at these numbers down here. Imagine that they're centimeter markings or meter markings or distance markings of some type. Using the standard sign convention, if the object is located to the right of the origin, we would say that the position is positive. If it's located to the left of the origin, we would say that the position is negative. When an object's position changes, we use the term displacement. It's defined as the change in position and is defined as the final position minus the initial position. Sometimes displacement is given the symbol lowercase d. You can see here in the formula, d equals delta x, or the change in x. X in this formula is the final position, x sub 0 or x naught is the initial position. Now, both position and displacement are measured in the metric system unit meters. The symbol is a lowercase m. The unit of measurement is typically considered to be part of the magnitude of a vector because it's associated with how far or how fast or how much. The unit is as important as the number when you're talking about how far away from the origin an object is. If I ask you where something is and you say 6, that's not enough information. There's a big difference between 6 meters or 6 miles or 6 inches. Okay, now it is easy to confuse position, displacement, and distance. All three have units of meters and indicate how far something is. However, distance, as we'll see, is not a vector quantity and does not have a direction. There are situations in which displacement and distance are the same, but only if the object does not change direction. Now, when we answer the second set of questions, is the object moving, how fast and which way, we're interested in how fast it's moving, and this is described using the term velocity, which has the symbol lowercase v. This is another vector quantity, which means that we have to include the direction when we describe velocity. Again, using the standard sign convention, if it's moving to the right, we say that it has a positive velocity, and if it's moving to the left, it's said to have a negative velocity. It's measured with the metric system unit meters per second, symbol m/s. Velocity is described as the change in position, or the displacement, as you might remember, divided by the time. You might also describe it as delta x over delta t. Frequently, we're concerned with the average velocity over a time interval. In these cases, we consider displacement over the time interval as described above. We're concerned only with where the object is at the start of the interval and where it is at the end. We're going to look at this in much more detail later on. We may also be interested in the instantaneous velocity of an object at one particular time. This is very well suited to graphical analysis, which we'll see in the very near future. It is important to note the distinction between speed and velocity. The quantities appear very similar and both indicate how fast you're moving. However, speed is not a vector quantity because it doesn't have a direction. You have a speedometer in your car. It indicates how fast the car is moving, but does not indicate a direction at all. What we're going to see is that velocity is associated with displacement because both are vectors, and speed is associated with distance. Neither are vectors. Now, when we're dealing with the third set of questions with an object that's moving, we want to know if its velocity is changing. Since we're dealing with one-dimensional motion, we just need to know if the object's velocity is increasing in magnitude, which means it's getting faster, or decreasing in magnitude, which means it's slowing down. If so, then the object has an acceleration. This again is a vector quantity, which means it has a magnitude and a direction. Acceleration has the symbol lowercase a, not to be confused with capital A, which means something else. The hard part about acceleration is visualizing the direction. Most people don't have any trouble visualizing the physical direction of position or displacement or velocity, but acceleration is harder. The easiest way to think of it is that if the magnitude of the velocity is increasing or the object is speeding up, then the velocity and the acceleration point in the same direction. If the magnitude of the velocity is decreasing or the object is slowing down, then the velocity and the acceleration point in opposite directions. The difficulty arises when an object is moving left. If its velocity is negative and it's speeding up to the left, its acceleration also points to the left and is therefore negative. If it's moving to the left and slowing down, the acceleration points to the right and is therefore positive. That's the tough one. So now, this visualization will help you a little bit. If both vectors, velocity and acceleration, point to the right, both are positive and the object is speeding up. If the velocity is to the right and the acceleration is to the left, these are opposite directions and the object is slowing down. Similarly, if both velocity and acceleration point left, they're both negative and the object is speeding up. If the velocity is to the left and the acceleration is to the right, the object is slowing down because these are in opposite directions. The velocity is negative and the acceleration is positive. Again, that's the tough one. So one way you can remember this, there are two ways for an object to have a positive acceleration that points to the right. It can either be moving to the right and getting faster, or it can be moving to the left and slowing down. That's the tough one. There are also two ways for an object to have a negative acceleration, which points to the left. It could be moving left and speeding up, or it could be moving right and slowing down. Acceleration is defined as the change in velocity divided by time. If you think about commercials for sports cars, a lot of times the ad will say something like the car can go from 0 to 60 in 4 seconds or something like that. The 0 to 60 refers to the change in velocity, because the car goes from a standing start, or what we call rest, up to 60 miles per hour in some time interval. The faster the car can change the velocity, the greater its acceleration would be. Okay? Metric system units for acceleration are meters per second squared, m over s squared, as you see here. Now, when we study an object's motion, very often we look at how its position and velocity change as time goes on. Time as a kinematics quantity is different from the others we've seen in that it's not a vector, because time does not have a physical direction. You might say that it only goes one way, it only goes forward, but it only goes forward in what's called a temporal sense, not in a physical sense. You can't point in the direction that time moves. So again, time is not a vector. It doesn't have a physical direction. Once again, we can look at time in a couple of different ways. We may be interested in the motion of an object over an interval of time, or we may be interested in what the object is doing at one particular time. Either way, the metric system unit for time is the second, and lowercase s is the symbol for seconds. Okay, so to summarize, we have the set of fundamental questions here, starting with where is it, has it moved, how far has it moved. These questions are answered using the quantity, position, or displacement. If we then want to know is it moving, how fast, and which way, we use velocity. And if we want to know if it's speeding up or slowing down, we use the term acceleration. Okay, that's the introduction. These are the quantities that you'll need to be familiar with moving forward. Alrighty, that is all. See you next time.